In this video, we'll talk about introduction to data science. So there are 9 things. Why data science? What is data science? What is data science process? What kinds of data can be analyzed? What kinds of patterns can be analyzed? Which technologies are used? Which kinds of applications are targeted? Major issues in data science and society. So why data science? So we live in a world where a vast amount of data are collected daily. It is a significant necessity to analyze such data to discover knowledge from it. So we are living in the information age. So it is a popular saying, but in fact, we live in the information age. Every day, terabytes or petabytes of data flow into our computer networks, the World Wide Web, and various data storage devices from the company, society, science, and engineering, medicines, and almost every other aspect of everyday life. Powerful and versatile tools are barely required to automatically discover and convert precious information from enormous quantities of data into structured knowledge. So, what is data science? So data science is a set of fundamental principles that support and guide the principal extraction of no information and knowledge from data. So data mining made the most strongly associated notion to data science, the real extraction of data information through techniques that integrate these principles. However, data science includes much more than just algorithms for data mining. Many businesses have strategically distinguished themselves from data science, sometimes to the point of developing into data mining businesses. From, data, from a data perspective, successful data scientists must be able to view the business problem statement. For data science, a big part of what has traditionally been studied in the field of statistics is essential. So what is data science processes looks like? So according to Fayette, data mining is one of the stages of the KDD knowledge data discovery method. I believe that the data mining stage primarily concerns the means by which the patterns are obtained and listed from the information. So Krebs DM framework was created through consortium attempts originally made up of Daimler Chrysler. So this Daimler AG and Automotive Company, SPSS for IBM and ACR. So CRISP DM stands for Cross Industry Standard Process for Data Mining. It consists of a cycle that consists of 6 stages. So first, business understanding. The initial stage focuses on understanding the goals and requirements of the project from a company view, then turning this knowledge into a definition of data mining problems and a plan for achieving the goals. So second, data understanding. The data understanding stage begins with the original data collection and begins with operations to get acquainted with the data, identify data quality issues, find first insights into the data, or detect interesting subsets to discover hidden information. Third, data preparation. The stage of data preparation includes all activities from the initial raw data to build the final information set. So for modeling, so different modeling methods are chosen and implemented in this stage, and their parameters are calibrated to optimum values. So fifth, so evaluation, the model or models acquired at this point are assessed more carefully, and the steps taken to build the model are reviewed to ensure that the business goals are correctly achieved. So final stage, deployment. Model creation is not usually the end of the project. Even if the model's purpose is to improve data understanding, the data acquired will need to be organized and displayed so it can be used by the client. So what kinds of data can be analyzed? So before that, we need to understand the definition. We need to know what kind of data they can be analyzed. So analysis can be applied to any type of data. as a general technology, as long as the data is relevant to target application. So database data are the most fundamental forms of information for analytical apps. So traditional DBMS, database management system, provides the relational database, which ensures their data integrity and transaction consistency. But the NoSQL, not only SQL, databases have emerged as a solution in the last few years. So witnessing the velocity of data growth and the lack of the support from traditional databases for this problem. So there are two types of database. So relational and NoSQL. So relational database, a database system consists of a collection of interrelated data known as database and a set of data management and access software programs. So a relational database is a set of tables assigning a unique name to each of them. So each table is made up of a set of attributes, columns or fields, and generally holds a large number of tuples, records, or rows. For relational databases, a semantic data model such as entity relationship data model is often built. So for NoSQL database, so the rapid growth in the amount of data and the issue of altering the schema the, the scheme database over the evolution of the distinct platforms were the first issues that motivated the NoSQL database further evolution. So most NoSQL systems are distributed databases or distributed data storage with a focus of high efficiency, high availability, data replication, and scalability, as opposed to an emphasis on consistency of strong query languages and structured data storage. Four types of NoSQL databases are available that can be classified based on their data storage. So these types are database based on key value, column based, document based, and graph. So this is how business intelligence looks like. How many sales transactions occurred in the month of December? So we can get this information based on the on a real-time scenario, but compared to the predictive analysis, which is was the data science applied, so they can searching for the trends or data patterns on the collected data. So then what kind of patterns can be analyzed? So there are many types of patterns can be analyzed, such as categorization and discrimination. So frequent patterns, associations and correlations, classifications and regressions, analysis of clustering and outlier analysis. Such analytics can generally be categorized as descriptive and predictive in two types. Data characteristics in a target information set are categorized by descriptive analytics. In order to create predictions, predictive analytics conduct induction on current data. Knowledge represents interesting patterns. So data categorization is a summary of the overall characteristics of features of a target class of data. So a query typically collects data that corresponds to the user's specified class. So this association analysis is a rule-based machine learning technique for finding interesting relationships in batch databases between variables. It aims to define strong rules that have been found in the database using some interesting measures. So as you can see, they have a list of transactions ID. So we take a look at transaction ID, which is the user behavior. You will already bought for bread and bread. So it can be at the same time it can be we can see it also will bought for milk. Then this classification is the method of discovering a model or function describing and distinguishing classes or concepts of data. So the model is obtained by analyzing a set of training data objects that are known to be class labels. So the model is used to predict the class label or objects that are known to the class label. So as you can see, this data set, so therefore ID employed, is it yes or no, level of education, graduate or high school, years of the present address. Then there's a target class, is it the creditworthy is yes or no. There, as you can see, there's a decision tree, and therefore categorical data type, and then the quantitative, so and then the class. So once this data set will be used as a training set, then we create a classifier to create a new modeling. Then this modeling we will test on the test data, which is anonymous. Then we can predict the output target class. Let's say for the second table, is it the employee, the ID first, is it the employee, yes, level of education, the undergrad, yes of represent 7, and then the category they will predict, is it yes or no. So this is a clustering, analyze data objects without consulting class labels, unlike classification and regression, which analyze class label training data sets. So clustering can be used to produce a data group's class label. So compared to the classification has a target class. Compared to cluster, they don't have. So they need how we can determine which this cluster is based on the characteristics. So there, as you can see in the graph, there are 3 clusters. So there are cluster 1, cluster 2, cluster 3. So I give an example. Let's say for cluster 2 is for amphibia, for cluster 2 for cluster 1 amphibia, cluster 2 mammalia, cluster 3 for reptilia. So the scientists have found a new animal, but they don't know which this animal belonging to which cluster. So how they determine it? So they will determine based on the characteristic, how the is it the blood is cold, blood cold or warm, or how have 4 legs or no, or have based on the is it fluffy or not, right? So based on this characteristic, we can see which is similar to which cluster. So if let's say it's similar to cluster 1, let's say is similar, then we belong to cluster 1. If 2, it will belong to cluster 2. So and then it goes on. Depends on the how similarities they are. So outlier analysis. We analyze data objects without consulting class labels, unlike classification. So, outlier analysis, where a data set may contain objects that do not comply with the general behavior or model of the data. So I give a simple scenario. Let's say for user behavior credit card. So let's say the bank will detect, let's say for monthly purchase around 1,000 average per month, and then at some point, let's say the 5th month, so they will detect the purchase behavior maybe around 5,000. So it can be like an outlier. So the bank will identify this is fraud. Maybe someone stole the credit card, so they can be can be the system will identify the bank, and then bank will tell the user is it the user buy the product or not, or the card have been stolen. So this is a sample of for the outlier analysis. So are all patterns interesting? It depends. So which technologies are used? For modeling data and data classes, statistical models are commonly used. For instance, statistical models of target classes can be constructed in data analytics functions such as data categorization and classification. Machine learning explores how computers can learn or enhance their efficiency. For example, a programming computer is a typical machine learning problem, so that after learning from a set of examples, it can automatically recognize handwritten postal codes on mail. Also, the database system and big data focus on establishing, maintaining, and using organizations and end users databases. In particular, data scientists in database system and big data have extremely acknowledged principles in data models, query languages, query processing, and techniques of automation, data storage, and techniques of indexing and access. In the processing of very big, comparatively structured data sets, database systems are often well known for their elevated scalability. Information retrieval is the science of searching for data in documents. Natural language processing (NLP) is part of the information retrieval field. So, what kinds of applications are targeted? So, there are two main major applications: business intelligence (BI) and web search engines such as Google. So, business intelligence techniques provide business operations with historical, current, and predictive views. So, clearly, the essence of business intelligence is data analytics. Web search engines are basically very large applications for data analytics. Search engines vary from web directories, in that web directories are retrained by a human, while search engines operate algorithmically or by a mixture of human and algorithmic input. So, what major issues in data science? So, there are three major issues in data science, which is methodology, user interaction, and efficiency and scalability. New data science methodologies have been strongly developed by researchers. In addition, problems such as data uncertainty, noise, and incompleteness should be considered by data science methodologies. The user plays a significant part in the process in data analytics. Interesting study fields include how to communicate with a data analytics system, how to integrate background understanding of user in analysis, and how to visualize and understand outcomes from the data analytics. Besides that, efficiency and scalability are always taken into account when comparing the algorithms of data analytics. So, data science and society. How is the effect of data science on society? What measures can be taken by data science to maintain individual privacy in our daily life? Do we use data science without even understanding what we're doing? This question poses the following questions. Social impacts. It is essential to study the effect of data science on society as data science penetrates our everyday life. How we can benefit society by using data science technology. How we can protect ourselves from misuse, improper disclosure of use of data, and prospective violations of the privacy and data protection freedoms of individuals are areas of concerns to be addressed. Publishing of data privacy and data science studies are underway. Data science will assist with scientific discovery, business management, economic recovery, and security, the discovery of intruders and cyber attacks in time. So, thank you for watching. Don't forget to like and share. Don't forget to like, subscribe, and share this video. Good night.